Hi everybody, I'm from the Siemon company and I'm with the technical support group, and we're a company that's out of Watertown. We do telecommunication infrastructure from copper to fiber to cabinets, just about anything that you would actually use or be involved in the use of transmission of data from point A to point B. What I'm going to talk to you today about is basically intelligent building as it relates to infrastructure solutions. Primarily the use of data cabling and four-pair cabling that you would traditionally use for your data applications to run PoE in various applications throughout your building, basically. And traditionally people, when you say this to them, they usually grab their wallet because the next expectation is that this is going to be a very expensive endeavor for them. But something that a lot of people don't realize is that in addition to, in some cases, an upfront savings in the actual implementation of the equipment you're going to be using, the real cost savings happens over the course of a year, where these systems, being low voltage power over Ethernet and managed systems, can actually reduce the cost that you would have for your whole system and for your expenditures, both capital expenditures and operating expenditures. So as you can see here, you might notice that when we talk about the PoE access control system, your traditional cost might be $351 per unit, and then a PoE device may cost you $280. So there's a little bit of a cost savings in the actual acquisition of the product itself. But then you may notice that if you go to something else like the HVAC VAV, which is the volume air control system, that actually comes out to be a little more expensive. But the bottom line that we really need to look at is when you come all the way down to the bottom, these systems, when you look at them over AC to actually the PoE operating costs, are significantly different. And when you stack these up on top of each other, you take in consideration LED lighting systems, control of your air conditioning systems, your heating systems, deployment of various light control systems with blinds that can come up and down on their own to get light and heat out from the sun. At the end of the day, you can have a cost savings of a couple $100,000, which in the big scheme of things isn't too much to really shake a stick at there, because you've saved that, and that's a recurring savings that's going to happen each year. So the way current state of affairs, as far as buildings that you're probably familiar with seeing that have been around for a while and have a legacy, is they're siloed systems. So that means that each department in these buildings has their own infrastructure, their own system network, their own devices that are being powered. So with that, you have dedicated power, you have operation support, IT protocols, standards protocols. It starts to become very convoluted because each of these departments is now running isolated from each other. That also can inhibit the ability for these systems to work together to help with these savings. For example, if you have a conference room in one part of the building that is getting very little use because, for example, the HR department doesn't utilize it as much as the marketing department may, it may be pumping ambient temperatures in there to keep it at a thermostat, the temperature of 68 degrees when there's nobody in there. With these systems integrated with each other, they can actually monitor and know through sensors if people are in there. And maybe the HR department, at the end of the year, after seeing this data, you can see, well, we've got some floor space that no one's actually using. We'll get into that a little farther on, but basically these silos drive up expenses and they run until they're obsolete. So there's really no upgrading of these systems at the time that you're currently using them. You end up at the end of life with them, and sometimes that's happening on separate time scales from other parts of the organization. So in intelligent buildings with our vision, all of the systems are run over data cable, basically, four-pair data cable systems. So it's IP protocols. That's an RG45 interface. So basically the data jacks that you would have running to your computer would now be utilized for things of the nature of Wi-Fi hubs. You'd have your lighting systems run over it for your LED lighting systems, sensors for your heating and your air conditioning systems, security cameras. The security cameras would be run over these 4-pair data cables. Smoke monitoring systems for the fires, emergency lighting. Everything can be integrated into these systems so that they work as a whole and they complement each other. And again, what this helps you do is it helps you have power and control over the data that's coming from these so that you can utilize it to optimize the whole picture. You can refine what your organization is doing, in many cases automated through the system itself so that you're not actually having to keep an eye on these things. It can refine itself and work almost like a completely automated system. And again, this will lower your capital expenditures and your operating expenditures. And a lot of this is coming down to zones, which is a particularly easy thing to do when you're talking structured cabling. Because structured cabling can be deployed to a zone and then actually branched out to these different devices, but over one central carrier. And that is your 4-pair highway, so to speak. It can be expanded and it can be adjusted on the fly also. It doesn't involve having an electrician come in and run a power cable that can cost a lot of money and can cause downtime if you have to bring circuits down. It can be done with the ease of a low voltage installer who will just actually put another patch cord in deployed to your IP device. So some of the attributed aspects of these converged systems is reduced installation time, reduced training, because you're not using a complicated system. A lot of these systems are software driven, where you can have master software systems that actually will work as easy as clicking buttons and driving menus. And many of these actually operate behind the scenes where they're not even visible to the average employee. They're very easy to change. So you can update and refresh the software that runs these components and further optimize them and adjust them for new devices that aren't even on the market right now. There's a certain set of devices that you're probably familiar with that would be for voice over IP, for example, with the phones. And the lighting systems are very popular right now that are starting to come on. But as time goes by, we're going to start seeing things that you may not even imagine powered by the power over Ethernet. I've even seen some, I have a slide of one that the musical instruments will be powered over these systems. You could have an electric guitar plugged into your structured cabling system that thus delivers to your PA system and pipes through the speakers of the building. So it's pretty much a limitless possibility that we're on the cusp of actually seeing these deployed right now. And it's going to become more and more prevalent as we go down the road. Another thing to keep in mind is that all of these different systems I've talked about traditionally would run over a variety of different cables. So you could have something that's actually running over standard phone cable, coax cable for closed circuit television, high power voltage lines for your alarm systems, electrical. These are a lot of different cables, and there's a lot of different techniques to terminating these. With the beauty of structured cabling, it all gets reduced down to a 4-pair cable for all of those applications. So one installer can put in the pathway for all of these to work without having to have different vocations, electricians, and so forth. It also cuts down on the use of having to have electrical conduits, which that is another aspect of cost that you'd be incurring besides the labor itself. This is just to give you an idea of some of the things I was just talking about from the workplace itself. Now you can see that this is an example of many things that would be powered over these power over Ethernet systems. From virtual receptionists that might be at a remote location that can actually operate 3 receptionist desks from one location, because you wouldn't actually have someone at each of those locations all the time. It would be sporadic. Information systems for particularly like you may have stock market information running across, you may have news running across, CO2 sensors, alarm systems, cameras. There's a variety of different things that you can have running on those. And all of these are joined by the fact that they are over structured cable. Again, the POA applications I just mentioned before, here's an actual picture of the electric guitar. But in addition to things that may occur to you with the heating and air conditioning, the closed circuit television, your Wi-Fi hubs, building automation, and so forth, other things are starting to get ramped into these as far as vending machines. These vending machines can actually feed live information back to the vending machine companies and tell them that they actually are getting short on a particular item. Soda, Coke. There's only 7 cans of Coke left in the machine. This is in the cafeteria where, you know, we're at 11 o'clock and lunch is coming and people will not be happy they don't have all the Coke they want. So, audio and video jukeboxes, they can actually pick the music they want. A lot of this stuff is happening right now to make more friendly work environments for employees. If employees are in a happy environment, they'll stay longer, they'll be happier about working, and some of that is being in control of your actual environment, whether it's being able to adjust the lighting above your desk from your smartphone, or possibly running your Pandora to the speakers in the cubicle, or the heating. You may have a heating vent above your desk that you can actually alter from your smartphone to make your environment more conducive to you being there and enjoying yourself. This is just an example of the PoE light. As you can see here, it's a 2x2 light, and the output from it is very bright. It's a very natural light pattern. It's not like a fluorescent light where it gives you shades that don't look true. It's almost like natural sunlight. And this can all be controlled by the system as a whole. So, for example, if you have someone in a conference room who's in one location, you may have sensors that realize that they're in one corner of the conference room, and it can dim the lights away from that person. Not enough that they may notice, but enough to bring the power consumption down. It can also work the same for windows. You may have lights that are near the windows of the building where sunlight's pouring in. There's no reason to light those lights because they're not doing any good because they're blinded out by the sunlight. So it can shut those off and again reduce the consumption. And these are some of the controllers that you would incorporate with your heating and air conditioning systems. Again, these can be adjusted automatically to sense how many people are in a room and know how much air delivery it's going to require to actually raise or lower the temperature to the desired temperature for that particular room. It takes a lot more energy to heat or cool a room that's filled with 20 people versus 5 people. And a dumb system wouldn't know the difference in that, and that would just keep pumping out the power. Major reason for going with PoE is cost savings. So as I had mentioned before, it's much cheaper to run a data run than it is to actually run a high voltage run. Just to give you some perspective on it, it actually will cost you, after labor, parts, conduit, and at the end of the day, you're looking at about $1,000 per location. As a case study, Purdue University installed 1,100 PoE wireless access points, and they were able to save about $1,000 per location. That's a lot of money when you think about it. It's actually coming down to about $250 per data drop. So you can see a real cost savings. Increased reliability. You have the ability with a PoE system to maintain continuity in the event of a power failure. It's much easier to maintain uninterruptible power over structured cabling than it would be for a standard lighting system where you may have to have the generator switch on for certain sections of the building, breakers. It becomes quite an ordeal. That's why you see a lot of emergency lights are battery run and will deploy as soon as the power goes down. Those batteries start to go bad after a while. You have to change them out. These power over Ethernet lights run at very, very low voltages. So you could actually have your uninterruptible power at a central location, and then the automated systems can determine how many lux of light are necessary to safely allow people to leave the building. It may shut lights down that are in corridors that it doesn't have to have them on. So you were able to maintain continuity in the building, and not just for lighting, but for different systems also. You could actually, we saw an example where a casino actually had billboards over all the slot machines, and these billboards were basically TV screens. They were flat screen TV screens, you know, these slots are paying out so much, you can win a car, and so forth. But in case of an emergency, they would switch over because of the home system that's inside the automation system to actually direct people out of the casino, and it can keep track of where they're going because of sensors, of mass movement sensors. So if you have a buildup in corridor A, for example, too many people are starting to go out that door, it will redirect them to another door. And yeah. And it also helps you with adds, moves, and changes too. It just is easier for you to move a 4-pair cable than it would be for any other infrastructure. This is just to give you an idea of some of the overlap of the conversion designs with the ease of deployment and the MAC work and improved pathway utilization. These are some of our products as they work into the big scheme of things. You can see we have quite a few products that are involved, from the basic cabling itself to the patch panels you have in your telecom room. We have enclosures above ceiling, plenum rated for air handling spaces. And basically we can deploy to all of these accessories and devices that you have. And this just gives you an idea of some of the versatility with your zone. You can actually overlap and have a coverage of 13 meters per zone. And that's just a quick summary. What's in the box? It's a bright future, and by using the POE system, you can plan for it because it's coming pretty fast. And thank you for your time.